Hi, everybody. My name is Walter Oczynski, and I would like to speak today about the most famous equation in finance, the Black Scholes formula. I would like to present today the alternative calculation of the Black Scholes model and discuss the meaning of ND1 and ND2. I find this quite interesting, but neither Black Scholes nor Merton explained or interpreted the ND1 or ND2. Cox and Rubinstein stated that the stock price times ND1 is the present value of receiving the stock if and only if the option finishes in the money, and the discounted strike price times ND2 is the present value of paying the strike price. I personally like the explanation provided by QuantPy in the YouTube video. You can find this on internet under the name An Intuitive Explanation, the Black Scholes formula. It is quite unfortunate that they provided the explanation under the assumption that interest rates and dividends of foreign interest rates are zero. You will find many explanations of ND1, of ND2. You see here a couple of examples. I will try to explain ND1 and ND2 as Z-scores of two populations with different means. I was very excited when I derived this interpretation, and I am sure you will find this cool as well. Let's start with a brief explanation of normal distribution and the Z-score as the preparation for introduction of our model. You see here the two distributions, two normal distributions with the same standard deviation, but different means. See, the most probable is that some event will happen as the mean, or you can interpret this as well. For example, when we take this left distribution with the mean of 0 and standard deviation of 1, when something, what is the probability that something will be less than 1? According to this normal distribution, you will see that this probability is 0 plus 1 standard deviation, so you have 50% chance that something happen is up to the mean, and then 1, it is 34%, so 80, it is with 84% probability that event will have the value, for example, smaller than 1. But on the same scale, you see now the similar distribution with the same standard deviation of 1, but with the mean of 3. According to this distribution, the value of 1 will happen with a probability of around only 5%. When I recall correctly, sorry, but it is less than 5%, 2.5%. So this is what you have, the impact of different means on the calculation of the probability. It is what I wanted to show with this chart. The second item, what we need in order to be prepared to the discussion of my model, it is the meaning of the Z-score. So Z-score is a standardized score, is a numerical measure of how far an individual score is away from the mean score within a normal distribution. A Z-score tells us how far individual score is away from the mean measured in standard deviation. And we can transform any distribution using the formula, which you can see here, into the standard normal distribution with the mean 0 and standard deviation of 1. In the time before Excel, it was a time when I learned statistics. We didn't have the statistical functions which Excel offers, but we used standard tables where only standard normal values for standard distribution were shown, and any other distribution which you normally encountered or something what you calculated was normally in different with different values. When standard distribution has to be converted into the to the standard distribution, and then you could look up the values, or you could look up in the first program of Lotus, which didn't have normal statistical function. I just entered the lookup table to calculate my Black-Scholes formula. So I am not sure, I don't know, but my interpretation is when in the 70s, Black-Scholes invented their famous probabilistic formula, they offered something what everybody could use immediately. So they introduced in the form of the Z-score, so this D1 or D2 in the Black-Scholes formula are Z-scores, which then, with help of the probability table showing standard distribution, the probability could be calculated immediately. What is important for further discussion of in this video, I am making the statement, please keep in mind that Black-Scholes model applies Z-score in the sense of cumulative Z-score. Z-scores gives the probability that a standard normal variable is lower than Z. Something is lower than Z. But when we want to calculate call option, we are interested in prices which are higher than strike price. So therefore, it's more practical to, instead of calculate Z-score, you calculate 1 minus Z-score probability. You can see this from this slide. The black shows me the probability of Z-score. Everything under this bell curve is 100%. So the black part shows me the probability of Z-score, and the blue part shows me the probability of 1 minus Z-score. Since it is the normal distribution, it shows the values from -3 to +3, and I just try to assume now logarithmic distribution, which shows the midpoint of 27, and -3 is around spot rate of 1.3, and +3 is the spot rate of 537. So the Z-score shows me 1 minus Z-score shows me the probability that the future prices will be higher than 27. This is the probability in blue. In the model which I used the calculation for the strike price of 25. I took the strike price of 25, spot price also 25, volatility 40%, maturity 1 year, interest rates 0.5% and dividends 0.4%. You will see this example in a moment. But now with the log normal or distribution for ND2 and ND1, I can show you it is relatively easy to explain when we have two different distributions. ND1 is a distribution with different mean than the ND2. And ND1 distribution shows, for example, that starting from the spot price of 25 with a volatility of 40%, it is almost impossible that the future spot prices will be below 1.24. So we see that the probability when the price is higher than 168 is almost 100%. That prices will be 1852 will be higher than 1852. It is the probability of 80%. And now we are coming to the strike price. According to the ND1 distribution, the probability that the strike price will be that spot prices will be higher than strike price, according to this distribution, is almost 60%. But when you look below on ND2, the probability that it will be higher, that the prices will be higher than strike price and the option is in the money, is 40%, around 40%. It is the difference between ND1 and ND2 is because they are different distributions with different means. If you have the different means, the probability for the same value is different. So now we are coming to the Blackshell's model. Blackshell's model is telling us that call premium has the discounted value of the spot price times the ND1 probability minus discounted strike price times ND2 probability. And how do we calculate ND1? Okay, we take the D1 value, and then we looked into the standard normal distribution table, or we use the Excel formula. In the model, what I suggest how you could easily calculate the ND1 and ND2, it is at first you calculate the mean. The mean is logarithm of the spot price plus 0.5 volatility square plus risk-free rate minus dividend, everything times time. And the difference to mean 2 is in principle that instead of Adding volatility square, half of the volatility square we subtract from the spot price for half of the volatility square. Since we are interested in the prices which are higher than strike price, we take ND1 as 1 minus logarithm function for from Excel or Google Sheet, which requires information about the strike price, and then the mean as calculated for this formula, and volatility. And when the time is different of 1 year, you have input the information for time. And since we are looking for the cumulative distribution, we have to enter true or 1. I can prove with this chart that what we did here with our model is in principle the same what Black and Scholes prepared with created in their model, calculating D1, because D1 is nothing else as Z-score, and Z-score is strike price minus mean divided by standard deviation. If you do this, you write down here logarithms of strike price minus mean as defined as spot price plus mean is plus volatility, but if I take them the whole mean, I subtract the whole mean, I have to write minus, and divide by standard deviation times square root of time. Now, if I divide and multiplied these brackets by -1, I receive spot price, positive spot price, negative strike price, and since they are logarithms, I can also write them as the logarithm spot divided by strike. Now, from the we divided this by -1. I am bringing now +1. I have also calculate change to plus interest minus dividend time. And now you see this is exactly what D1 is. So I calculated D1 based off the distribution, which has the mean as per definition provided. What I didn't discover the mean, what the mean of the distribution is. I just went in different direction. I had the D1, and then using this formula, I calculated what is value of mean, and then this calculated backwards in principle the mean from D1 and the second mean from D2. You can see on this chart the end of the story, the working model to calculate call premiums according to probability and the mean involved. No, we don't need to go the way through the Z-scores as it was done by Black and Scholes, but we can do this according to what we have today at our disposal. We have the Excel with all the statistical functions at our disposal. Why is the need to calculate Z-scores anymore? No, it's not. What we do, we have the in this case, spot price of 25, strike price of 25, volatility of 40%, time is 1 year, dividend is 0.5%, and the risk-free rate is 0.4%. We calculate the mean for ND1. We calculate the mean for ND2. What we then still need, we need the formula for 1 minus log normal distribution and 1 minus log normal distribution for D2. And in our model, we see the probability according to 1 minus log norm distribution with the mean for ND1. So it is the probability of 56% times spot price. We obtain the value of 13.5. Now we take volatility and the probability according to ND2, and according to ND2 is 41.10%, multiplied with the strike price. It is of course discounted, and we obtain 9.887. And this results in the call premium of 3.67. It's exactly if you would calculate this to well-known Black and Scholes procedure. So this is in principle the model. It can be used easily by everyone. I just show here on the last slide formulas which were used, so you can, in case if you would like to recreate, you can easily enter the formulas into your spreadsheet. Hope that you like it, and thank you very much for listening. Bye.